Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Maxwell's House is brought to you by Cachefly at CACHEFLY.com.
This is Maxwell's House with Ray Maxwell and Dr. Kiki Sanford. Episode number 73. Where am I?
This episode of Maxwell's House is brought to you by Squarespace.com. For a fast and easy way to build a website or a blog, you can go to Squarespace.com and get a 10% discount when you use the promo code HOUSE. Welcome, everyone, to episode 73 of Maxwell's House. I'm Dr. Kiki, and Ray Maxwell is here once again to give us all sorts of information about aviation and planes. Hi, Ray. How are you?
I'm doing great. How are you doing?
Fabulously.
All right.
Where are you?
Where am I?
Where are you?
That's right. Well, today I'm in Vancouver, or actually Delta, British Columbia. But that's a good question for pilots. And today we're going to figure out where we are using different techniques of navigation when you're flying an airplane. So we're going to discuss all those different techniques later on in the program. But before I do that, I've got a few announcements. Of course, in the last few shows, I have made the shift at the request of the producers of making Maxwell's House an aviation show, because it is one of my favorite topics, and there does seem to be a large following for it. So Maxwell's House is going to be about aviation, and we may even change the name of the show. We're researching that right now. But in addition, I'm happy to say there have been a few people who have written in and said, but Ray, aviation is nice and all that, but I'd really like to hear more about digital photography and color science and, that side of your personality. So the good news is last week I appeared as a guest co-host on This Week in Photography, and am scheduled to do so from time to time into the future. So those of you who want to hear me discuss digital photography, color science, and topics like that, I will be appearing on This Week in Photography as well.
Cool.
Yeah. So, you don't have to give up on hearing me talk about those topics.
Good.
Now, this week, I'm going to replace the segment. I usually go through the aviation news, and there isn't a whole lot of new news. They're still fighting the particles from the volcano, and there's great discussions about how bad they are and how safe it is to go near the clouds and so forth. But that's becoming slowly old news. So this week I'm going to substitute a short story out of my past about aviation news and a story. Well, I'm not going to give it away. I'm just going to say, while I was working at McDonnell Aircraft, this is back in the 60s, I worked on a number of classified projects. And in order to work there, you had to get a clearance. And while I was working there, I had the lowest clearance is confidential, and that's fairly easy to get. The next thing is secret. Then you could move to top secret. And if you worked on encryption equipment, you had to have a top secret crypto clearance. And I eventually had that highest clearance while I was working there. And they even went back to my hometown and interviewed everyone from my teachers to my scout leaders. I mean, they really check you out because you end up with access to codes, for secret information. And of course, if the wrong people get a hold of those, they could do serious damage. Now, that wasn't the project I'm going to tell you about. The truth of the matter is, I don't even remember this project, but I remember about it quite clearly. Now, when you work on classified projects, they only tell you what you, and now here's the operative word, what you need to know.
I've heard that before.
Right. So if you don't need to know, you don't get the information. They only tell you just enough information that you can perform your job on this particular project. And depending on what you're doing, sometimes you don't even know what the thing is all about. And that was the case. I got put on this project, and they told me enough for me to design and wire up this little test facility that I was building, but I had no idea what the stupid thing did. And so one day, my boss came back through the lab, and I was working on this thing, and I said, my curiosity is just killing me. I said, can't you tell me anything about what I'm working on? And he said, no, Ray, the security regulations are very strict, and we can't tell you what you're working on. I'm really sorry about that. So a few weeks later, I'm still working on this project, and my boss comes back and he says, Ray, says, the project you're working on? I said, yeah, I know the project. I don't have a clue what it does. He says, well, I can't tell you. You know that. There's strict regulations. But he had a copy of Aviation Week, the magazine. This is a very popular magazine and so forth. He says, well, I can't tell you anything about what you're working on, but I think you'd be really interested to read page 41 in this episode, or this issue.
This issue, yeah.
Of Aviation Week, and handed me the magazine with a big smile on his face and walked away. Sure enough, I turned to page 41. Here's a whole write-up on the project I'm working on. Now, here I am at the company doing the project, and they can't tell me what it's about. And here's a whole write-up on the project in Aviation Week.
I love it.
Now,
nice.
Remember that this was at the height of the Cold War. This was the 60s. And I don't know whether this is true. I have no idea. But there were people where I worked there at McDonnell who actually referred to Aviation Week as Aviation Leak. Okay. And there was speculation that this magazine, now this is wild speculation, I don't believe this is true, but there was speculation that this magazine was published by the CIA.
What?
And that it was an attempt to give misinformation about the projects and to fool the other side. Now, there were a lot of...
What's the truth in that?
I have no idea, but that was what it was referred to as Aviation Leak, because time after time we'd be working on a project, and if we wanted to know more about it than they could tell us locally, we could read about it in Aviation Week. So that's my news story for the week, and how we got our news back in the 60s while working at McDonnell Aircraft. We'd find out about the projects we were working on by reading Aviation Week.
That is so perfect. Yeah. I love it. It just makes me wonder, if you work in a classified government agency, you just have to figure out which magazine you need to subscribe to.
That's right. Exactly. That's the way you learn about what it is you're working on.
I love it. What questions did people have for you this week? Your answers for there aren't classified, right?
That's right. No, I can talk all about them. And after I answer them, I won't have to shoot them. So.
Good. I will not have to kill you. Yes.
Right. Okay, the first question that I've picked out of the mail pouch this week is, where do runway numbers come from? You hear if you listen to aviation radios or air traffic control, the tower, you'll hear someone say, cleared to land on runway 24 left. Cleared to land on 08 right. or whatever. What do those numbers mean? Well, it turns out it's really simple where those numbers come from. If you are told that you're going to land on runway 08, if you add another 0 to that, so 080, that is your magnetic heading at the time you line up for that runway, plus or minus 5 degrees. In other words, they round it off to the nearest 10 degrees, and they drop the last digit, and that's how they number runways. So runway 18, you'd be heading straight south, 180 degrees, magnetic heading when you line up for that runway. Now, if there are parallel runways, then you'll have 18 right and 18 left if you were landing to the south. Now, keep in mind that every runway has 2 designations. If you're landing on to the south, you would be on runway 18. If you're landing on the same runway going the opposite direction, you're landing on runway 0. Okay? So I'll move it over to 90 degrees just to illustrate it. Runway 09, you'd be landing to the east. And runway 27, you'd be landing on the very same runway from the opposite end. Your magnetic heading would be 270 degrees. So that's where runway designations come from. And then they have left, right. And at a few airports, they have 3 runways in parallel, and they'll go left, right, and center. So 08 center, or 08 right, or 08 left. And so from that call, you know which of the runways you're landing on. And usually you dial in an instrument, like if you have an HSI, heading situation indicator in your aircraft, you'll put your arrow to the runway heading so that as you fly the pattern, you can fly the correct base leg and the correct final approach to that runway. So that answers that mysterious question. Then what is de-icing fluid? Oftentimes, if you're in northern climates like Canada, or you're in Minneapolis, St. Paul, I used to fly in there a lot on business, and before we would take off, we would leave the gate, taxi to a special area, usually near the end of the runway, and big trucks with, what do they call them? These things that people go up in to work on telephone poles and stuff. They would have people in those with big sprayers, and they would spray the whole aircraft with what's called de-icing fluid. And the object of that fluid is to, number one, remove any ice, snow, or what have you from the outside of the aircraft just before takeoff. And depending on the fluid they use, some of it actually will last for a while and prevent ice from forming as they're climbing up through the clouds. So the whole object of the game is to de-ice the plane as close to takeoff as possible. That's why the de-icing areas are usually somewhere near the end of the runway. And an interesting thought on that is if you use, for instance, there's a de-icing fluid made by Dow Chemical called UCAR fluid, and it freezes at minus 28 degrees Celsius. And, of course, we know that water freezes at 0 degrees Celsius. But if you combine those two fluids, something interesting happens. The combination of water and the UCAR fluid makes the freezing point drop to minus 55 degrees Celsius. So combining the de-icing fluid and the water actually lowers the freezing temperature below the individual freezing temperature of either of the liquids. And so that means that any supercooled water that you hit while you're climbing through the clouds, it reduces its freezing point. So that's what's in the de-icing fluid that's sprayed on your aircraft just before takeoff, if you've experienced that in the wintertime.
And you can say thank you for spraying my plane. Yes.
That's right. I always feel much better when there's snow falling, and you know and especially if the temperature on the ground is real close to freezing. That's where you have the biggest danger of picking up ice, as we discussed last week. Now, the next question I did a whole show on parachuting, and I mentioned the fact that once you reach terminal velocity in free fall, you don't feel like you're not accelerating anymore. You don't feel like you're falling, and you feel like you're being held up on a big feather bed or something, and you're just floating up there, and the ground is not rushing at you because you've jumped out at 12,500 feet. You've got a minute of free fall ahead of you, and you can look down on the ground and you can see objects and pick out the airport or wherever you're jumping into. And it's quite an enjoyable sensation. So one of our fans wrote in and said, well, is there ever the possibility that you can get so, blissed out on this feeling of free fall and turning and soaring that you forget to pull your ripcord? And I personally never experienced that much. I mean, I loved free fall. But I always very much kept in mind that I needed to open the chute. And I always opened my parachute at 2,800 feet above ground. Now, there's some parachutists that open lower than that nowadays. But at 2,800 feet above the ground, if you're at terminal velocity, it means you have 16 seconds of free fall. In other words, if you pulled your ripcord and something went wrong and you still stayed at 120 miles an hour or 176 feet per second, you've got 16 seconds of free fall left to do something about it. And actually, 16 seconds is a long time in those circumstances. Now, on top of that, in case you would get totally blissed out. Now, by the way, you wear an altimeter. We wore an altimeter and a stopwatch. And we cross-checked those during the free fall. We would look down at our altimeter and our stopwatch and cross-check those to make sure of how high we were at any given instant in the free fall. And if you're on a long free fall of 60 seconds, that's a long time. And you have plenty of time to glance down, check your altimeter, and see where you're at. Now, in addition to that, we also wore an automatic opener on our reserve chute. This is a device that has an altimeter and a rate of fall sensor in it. And if you go through 1,000 feet, and by 1,000 feet, you've only got about 6 seconds before you hit the ground. If you go through that altitude and you're still falling faster than 100 feet per second, then it will fire automatically. It's a pyrotechnic device, and it'll pull the ripcord on your reserve chute. And the place where that's most important is if you're doing what they call relative work in free fall. If you are free falling with other people and you're connecting up and holding hands and partying and all this, if you don't see where the other person is when you're first joining up, and you have pulled your arms back and you're flying forward at a high speed, you can collide up there. I mean, the odds are very slim that this will happen, but it has happened, and people have collided in midair, and it's knocked one of the parachutists out.
Yeah, that's what I was going to say. If you're traveling you are traveling at a high rate of speed, and so if you are two objects that impact, you're going to have quite a collision. So that could knock people out, and you'd want something
right
that would make up for that. If you can't pull your ripcord, who is going to?
Precisely. So we did wear, or at least I wore, not all parachutists did, but I wore an automatic opening device. And as soon as I opened my main chute, looked up, saw that it was okay, then I would manually disarm my automatic opener. I mean, it had an automatic disarming facility, but you don't want to open two parachutes after you've got one perfectly
That's
good
what I
one.
was going to ask, if that has ever happened. Somebody opens their chute and then the automatic one opens, and suddenly do they tangle and do they collapse each other? Does that become...
Well, yeah, most of the time they don't, but it can happen. And you certainly don't have the control that you do under one good chute that's steerable. Yeah. You've got two chutes, and you usually start circling each other. and you just land wherever you're going to land because you don't have much control. Now, I know of one occasion where a parachutist had the second chute open accidentally, and he actually pulled it in and stuffed it back in and tied one of the bungee cords around it, so he had control of his main chute. So at any rate, that answers that one. Now, the next one I had was an interesting question, and I have to somewhat guess what the fan had in mind. He said he was on a flight recently, and I think it was a commuter airline, and he said that during takeoff and during approach, there were a lot of times when the engines sounded to him as though they were spooling up and spooling down, kind of up and down. And this bothered him. He said, was something wrong or is that normal? And I believe there are two possibilities that of things he could have experienced that are completely normal in a turboprop aircraft or a propeller-driven aircraft for that matter. One, the RPM of the engines, both on a piston or a turbine aircraft, are controlled by the pitch of the propellers. So in other words, they have a governor and you have a lever and you set the RPM you want, and it varies the pitch to vary the loading on the engine to maintain a constant RPM. They're referred to as constant speed propellers. And after you take off, you have the propeller set to fine pitch to develop the most thrust. And then after you lift off and you've established the climb, you pull back both the power or torque, and then you pull back the propellers, and you will hear the RPM change fairly suddenly as you adjust that RPM. In addition, if there are more than one engine on this aircraft, if it's a twin or four-engined aircraft, there is a prop synchronizer that you can turn on and you can adjust. You can do it manually, or in some airplanes you can do it automatically, where you synchronize the propellers to get the exact same RPM. And if you don't have them synchronized, and sometimes the pilots are too busy for a while after takeoff to go through this procedure, sometimes the automatic part doesn't work. And if the propellers are not exactly at the same RPM, you'll get what's known as beating. And so you'll get this wow, wow, wow. And it's very disturbing and kind of ominous sounding, but there's nothing wrong. The two propellers are developing thrust. They're just not synchronized precisely. And eventually, usually the pilots get around to synchronizing the propeller RPM, and then that goes away. But, you can definitely hear this beating sound, and it is disturbing, especially if you're sitting right in line with propellers. I've been on a few flights, and this thing's going, wow, 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 and it's uncomfortable to your ears. It's a real, kind of low-frequency beating. But again, there's nothing wrong. There's nothing to be worried about. There's nothing dangerous happening. Have you experienced that on the turboprop?
I have not personally, no.
Okay.
No.
Been flying mostly the big jets, huh?
That's right. I try and stick to the big jets. I just think that they've got a lot more power, and their ability to stay in the air is a lot safer. I don't know. Little planes make me nervous.
Well, the turboprops, if you fly on them a lot, you'll definitely experience that.
Yeah.
Now, the next question that was a fellow noticed that just by looking at the schedules, that when you fly from North America to Europe, the flight is shorter than when you fly from Europe back to North America. And he asks, what's the reason behind that? Does it have to do with the rotation of the Earth, or what is it? And it turns out it has to do with the prevailing winds and somewhat the jet streams. But the prevailing winds in the higher northern latitudes are from west to east. And there's a circulation that happens in the upper atmosphere where the winds move from the southwest to the northeast in the higher latitudes. Now, down near the equator, that's not true. It's the reverse. The circulation is opposite. The trade winds at near the equator travel from east to west. And so if you're at lower altitudes and near the equator, you can go, from the east to the west easier than the reverse. And the sailing ships took advantage of that. You can't, if a lot of people say, well, why don't airplanes then go down to the equator every time they go? Well, if it's too far out of the way. If you go down to where the winds help you go from east to west, the distance you have to travel to take advantage of them does not outweigh the advantage you get by traveling in them. So that's why when you fly from Europe on the North Atlantic tracks, which is the normal route, when you travel from Europe back to the North American continent, it's a longer flight than going over. So it just has to do with the circulation and prevailing winds. And the same thing happens, by the way, in the southern hemisphere. You have the same problems. But near the equator, it's east to west that is favored. And in the higher latitudes, both in the southern and northern hemisphere, it favors going from west to east. So I think we've covered that one. And then I got an interesting question, and I don't know exactly how to answer it. But he said, I find your outlook on life to be interesting. What is your outlook on life? And I will condense it greatly. But as people who know me, and Leo knows me fairly well, he always refers to me as a polymath because I am interested in many, many different things. I've flown all kinds of aircraft and hot air balloons and model aircraft and gliders, and I scuba dive, and I've skied, downhill skiing, cross-country skiing, and I have a fascination with technology of all kinds, our research and development science, and all of these things. And my outlook on life or philosophy of life is suck as much out of it as you can. Just, pack as much in, because I'm 65 now, and I've learned, boy, life goes by in a hurry. and so you want to, investigate and learn as much as you can in as many areas. And finally, the thing I find the most fascinating in life, at least to me, is people. People are extremely fascinating, how they think, what they think about it. And I think the human mind is one of the last frontiers that we're only starting to really investigate. And I find it very interesting that many of the high-tech people that have made it big in Silicon Valley are now studying neuroscience and are interested in the human brain. So there's my nutshell of that's my outlook or what motivates me in life.
I would tend to agree with you there, and I think you're definitely doing a great job. Considering all the stories that you have to tell of sucking the marrow out of life and just living life to its fullest and trying all the things that you can. Like, it's just amazing, just amazing. More, keep going. 65 is just a beginning.
Well, I'm trying. I'm doing my best.
Do we have time now for our sponsor message?
Indeed.
This hour of Maxwell's House is brought to you by Squarespace. Squarespace.com is the fast and easy way to publish a high-quality website or blog. For a free trial, you can go to squarespace.com and enter the promo code for 10% off. Enter the promo code HOUSE. For the promo code HOUSE, you get 10% off of your account that you sign up for at Squarespace. And so what will you get by signing up at Squarespace? They have a really easy to use user interface for creating websites and blogs. And the way that everything works at Squarespace, if you have Blogger or WordPress or another blogging platform that you use, those can be incorporated into the site that you develop through Squarespace. They have all sorts of templates that you can choose from that are pre-made for you, or if you know CSS, you can actually, design one yourself. Through Squarespace, they will host your site. They give you this easy way to design and build your site and allow you to publish content all the time. It's easy. And they're giving you 10% off for listening to Maxwell's House if you use the promo code HOUSE. What else do we have? If you have photo galleries, you can add photo galleries to your Squarespace website. You can add forums to your Squarespace website. They have Google Maps. You can collect email addresses. So if you're interested in building an email database of some sort, you can do that as well. They have tracking information and search engine optimization strategies as well to get you better placement in the search engines. And they have permission access handling. So if you can decide who gets to access your website and how they get to access it, there are all these things that are available for you. Squarespace really is the easy way to build your website. Build it, host it, manage it, squarespace.com. Promo code HOUSE, you get 10% off. Thanks to Squarespace. And now we get to find out where you are.
That's right.
Yay.
Where am I? Well, I thought I would just briefly now, and the truth of the matter is it depends on how deep I go into this topic, because it's an unending topic. We may have to cover some of this next week. There's so many topics popping up. But what I was going to say today is about how pilots navigate and all of the different methods of navigation that they have to learn how to do to be a proper pilot.
Yeah.
And the most basic of the navigation skills is called dead reckoning.
Ah, birds have that.
Yeah.
I think bees have it as well.
Something like that. Mm-hmm. Yeah. I'm not sure. Birds and bees, I think, now we're talking about the birds and the bees. Well, yes. Anyway, at any rate, I think in many ways they rely more on what pilots would call pilotage.
Ah.
But we'll get to that.
Okay.
Let's jump into dead reckoning. What do you need to do dead reckoning, and what is it?
A sense of direction?
You have to have a compass. You need a map that you can measure distance on, and you need a clock. Huh? Because basically the idea behind it, and you need a winds aloft forecast. So you need those basic things before you can do dead reckoning. What you do is you plot your course on a map, and we could go off down a rat hole here on what kind of map, but most aircraft maps, sectional maps, are called Mercator projections, and that is a projection of a sphere. The Earth, of course, is a spheroid, and it is a way to represent that spheroid on a flat piece of paper. And if you draw a straight line on it, you get a great circle route. So for short distances, it really doesn't matter a whole lot. But what you do is you plot your course on the map, draw your course line. You then, with a plotter, measure your true course. And this is from true north. And then you have to add or subtract the magnetic variation. Now, what's variation? Variation, it turns out that magnetic north is not at the North Pole. It's up somewhere between Greenland and Baffin Island, or one of the other islands up there in northern Canada. And depending on where you are on the Earth, there will be an error. And if you look at any aviation map, there are lines of a variation. Here in Vancouver, the variation is as much as 23 degrees east. And if you're in Missouri, where I learned to fly, it used to be around 8 degrees. And by the way, it varies with time. They have to correct the variation because that magnetic pole over time, over my lifetime, those variation lines have changed 2 or 3 degrees. So you have to look at the map and see what the variation is, and that gives you a magnetic course. And then you have to do a further correction for the metal objects that are in the plane that cause the compass to deviate. That's called deviation. And you have a little chart in the aircraft that tells you what the deviation of that compass is. And then even before you do the variation and deviation corrections, you have to allow for the winds that you're going to be flying. Because if you're trying to fly straight north and there's a wind out of the east, it's going to cause you to drift and not go in the direction you're pointed. So you're going to have to correct by shifting your direction into the wind slightly to allow for the drift caused by the wind. And in addition, that's going to slow you down. Now, all of these corrections, you finally come out with a magnetic heading. And that is the compass heading that you fly in the aircraft. And if everything is done right, you will arrive at your destination. And of course, the other thing you calculate is what is my ground speed given the winds. When you have calculated that, after you take off, you check on that to see if the wind forecast is accurate. You go over a point on the ground that you can identify, some intersection of roads or railway tracks or another town, and then you time to another point on your map, and then you get out your E6B analog calculator, and you calculate your ground speed based on actual data and compare that to the forecast ground speed that you did with the upper winds forecast. You also check to see that you're drifting the amount forecast. Now, that is dead reckoning in a nutshell. And I've got a question for you, Kirsten, to see, well, this is, and by the way, this is a tougher question than it sounds like. and I've even had some very experienced pilots blow it on this.
Okay.
Now, imagine that I have an airplane that will fly 100 miles per hour.
Mm-hmm.
And I'm going between 2 points that are exactly 100 miles apart.
Okay.
Okay. So I'm going to fly from A to B, and I'm going to instantaneously turn around at B and fly back to A.
Okay.
And there's no wind. All right? No wind at all. So how long will it take me to fly from A to B, instantly turn around, and fly back to A? Now, the 2 points are 100 miles apart, and the aircraft's true airspeed is 100 miles per hour.
Well, you would want to say 2 hours, but you're...
No, that's right.
Yeah, okay.
All right.
I'm like, what are you doing here that's going to trick me?
No. So far, you're right on.
Okay.
All right. Now, the question is, imagine that I have a wind, let's say from 45 degrees, a headwind that's 45 degrees off our nose, and it's blowing at 15 knots. Okay? Okay? So it's on our right. It's going to push us to the left, so we're going to have to alter our course to the right to correct for it.
Mm-hmm.
But I'm going to do the same flight. I'm going to fly from A to B, instantaneously turn around, and fly back to A. How long does it take me to make the round trip?
2 hours?
No.
No, it's the difference because you have the headwind that's 15 knots, and then it's a tailwind that's 15 knots. So
That's right.
Is that going to cancel? But it
All
doesn't
right,
cancel.
Let's exaggerate the case.
Okay.
All right. What if I fly from A to B and I have a headwind of 50 miles per hour right on my nose?
Mm-hmm.
How long will it take me to fly from A to B? Forget about the return trip.
2 hours.
2 hours.
Yes.
Am I going to fly back instantaneously?
No. Yeah, no.
No. So
So it would be a half an hour back. Would it be a half an hour instead of an hour back?
Well, it'd be 150 miles an hour, 100 miles an hour. It's not a half an hour. It's 2/3.
2/3. Okay.
Okay. So it's going to take me 2 2/3 hours to make the round trip. So here is the bottom line on this. Anytime there is a wind blowing and you make one of those instantaneous round trips, okay, the time that the wind works against you is always longer than the time that it helps you.
Yes.
So the round trip always takes more time if there's a wind blowing from any direction, a crosswind right across 90 degrees. It's still going to take you longer to make the round trip. And of course, I have a story. There was a pilot here in Vancouver who, and by the way, remember in an earlier episode, I told you have to carry 45 minutes of reserve fuel. Okay? You're supposed to always have extra fuel. This pilot flew up to a place called Williams Lake, which is, I don't know, about 200 nautical miles away or so, and dropped off a passenger and flew back to Vancouver. And he got within sight of the airport and his engine quit. And he ran out of fuel. And he landed on the Hudson Street Bridge, which is like, maybe 2 or 3 nautical miles from the end of the runway. In other words, he almost made it. And it was funny. The newspaper wrote it up and said, he did such a spectacular job of landing on the bridge and not hitting anybody. And wasn't he a hero? And, of course, all the pilots in the Lower Mainland are going, the stupid idiot ran out of fuel.
Dumb.
So when the pilots questioned him about this and said, what possessed you to, think you could make this trip and not run out of fuel? And he said, well, I'd done it 3 times before. And he had flown to this place before, but there weren't stiff winds. Okay. And he thought, well, if I've done it, no matter what the wind is, just like you first said, the round trip is still going to be 2 hours. Anytime there's a stiff wind blowing, it takes more fuel to make the round trip. And he didn't allow for that and, nearly damaged himself. So,
but he was a hero in some people's eyes.
That's right. He was a hero in the newspaper reporters, which know nothing about flying.
That's so funny.
Yeah. So there you go. That's a true story. He had done it 3 times before and got away with it. Obviously, he wasn't carrying 45 minutes of reserve fuel. He just barely had enough to make it in no wind conditions. And he thought, well, whatever I lose flying into the wind, I'll make up on the way back. Not true. All right. The next mode, which goes hand in glove with dead reckoning, is pilotage. And pilotage is very simple. It is the art and science of looking out the window and identifying objects on the ground and picking those same objects out on the map. And by the way, you're taught as a student pilot, always look out and find distinctive landmarks on the ground in the real world and then try and find them on the map. Don't look at the map and then try and look out and find the things you've seen on the map. In other words, start with reality and then work to the abstract representation. Okay.
I kind of like that in general. Start with reality. Just words to live by there.
Remember we talked about look at the data?
Yes.
Okay. Yeah. This is look at the real data.
And what's around you?
Yeah. And then go and try and match that to figure out where you were. And there's all kinds of classic stories about pilotage techniques. One of them in the Midwest where I learned to fly was if you get lost and can't figure out where you are. And by the way, the Midwest is laid out in a grid, all the section lines. It's not hard to tell where north, south, east, and west is because there's section lines all over the place. And if you fly over the Midwest, you can see this very clearly. The only trouble with that is there's a little town in the middle of every section, and it has a highway running through it north, and another one north-south, and another one running through it east-west, and usually a railroad track running through it diagonally. There must be 10,000 little towns that fit the description I've just given, and they all look alike.
I grew up there.
Okay. You know what I'm talking about.
Yeah.
All right. So one of the tricks as a student pilot, if all else failed, you went down and you circled the water tower and read the name on it. Okay. And the other one is if all else failed, you followed railroad tracks or roads if you lost your dead reckoning. Now, I learned to fly in the Midwest in Missouri, and it's the best place on earth to learn to do both dead reckoning and pilotage because it's very difficult. Navigating here around Vancouver, we send our student pilots. We can't send them out over the water. We can't send them down into the U.S. On the north side of Vancouver is all mountains. So the only place they can go for a practice cross country is to fly out to Hope, BC, which is down the Fraser Valley and back. Well, they're like a marble in a rain spout. You know, they've got mountains on both sides of them. How can they get lost? You know?
Just don't go out of the valley. You'll be fine.
That's right. Stay in the valley. You're gonna find, hope at the end of the valley, and that's interesting. Okay, I can't pass up. I can't pass up this story. This is really digressing, and it's not aviation, but it's a local story that I love. Hope, BC is at the end of the Fraser Valley, and it's where the Fraser Canyon starts. And any rate, a good friend of ours who was a minister, a preacher, and he had a daughter. And when she was about 10 years old, they were driving up the Fraser Valley, and they'd gone through Hope, and they had just turned north to go up the Fraser Canyon. And she was a very quiet kid, but had this wit that wouldn't wait. And she turns to her father, a minister, and she says, "Well, Dad, we're beyond hope, and we're headed for Hell's Gate."
Oh, my gosh.
Because that's the next place up the road from Hope. I love that. We're beyond hope and headed for Hell's Gate.
Literal.
Literally. Okay. So, any rate, back to pilotage. Pilotage is easy in the mountains where there, especially if there are major mountains, like in our area, we have Mount Baker, Mount Garibaldi, and we have the water to the west of us, and we can see Vancouver Island. It's really not difficult to navigate by pilotage around here. As long as you have good visibility, you know exactly where you are. So, any rate, next week, I'm going to go on to talk about all kinds of radio navigation, automatic ADF, VOR, DME, ILS, and finally GPS. Rather than rush through any of those today, I'm going to leave off with the basics of dead reckoning and pilotage. And again, pilotage is looking out the window, seeing what's out there in reality, and then figuring out where you are on the map. Now, I'll tell you a true story. I had a student pilot, and this guy was he was an engineer I worked with at McDonnell Aircraft, and he took flying lessons from me while I was instructing in St. Louis part-time in the evenings and weekends. And this fellow, he had a terrific physics background. He understood all about aerodynamics. He was an electronics engineer. And he was just certain that after reading books about flying and everything, that he was going to be able to get into an airplane and fly it correctly the first time. Now, he didn't understand that the first thing you have to learn is eye-hand coordination, and this has nothing to do with intellect or book learning. This is teaching your body to react. This is like learning how to juggle, how to ride a bicycle, how to play tennis, how to ski on snow. All of those have a lot more in common with learning the basics of flying than your intellectual understanding of aerodynamics or how flight controls work or what have you. And a lot of people don't understand that, so they're just sure. So at any rate, he had quite a rough time in the beginning because he was very disappointed in himself that he didn't instantly know how to fly. And then I went on his dual cross country with him, and I had tricks up my sleeve. I told him that, number one, he could not use radio navigation. We flew in a triangle, and I said, I want you to fly, from A to B to C and then back to A. And you can't use any radio navigation in the first part of the flight. You have to do it by dead reckoning and pilotage. And so I'd let him fly the first leg, and usually that went quite well. And then in the middle of the second leg, I would take over control of the aircraft, and I would say, I can't remember how I did it, but I would divert his attention completely to some task in the cockpit. I'd ask him to calculate something. And in short order, I would gradually turn the plane off course and basically leave the course that he had planned. And I would get him lost without him really knowing what was happening. And then when he had finished with his head down doing this calculation in the cockpit, I'd say, okay, figure out, show me where you are on the map. And oh, by the way, I've changed, there's bad weather ahead. Now, there wasn't any bad weather, but I'd make this scenario. I said, there's bad weather ahead, and I want you to fly me directly back to A from here. But first, you've got to figure out where you are. Well, this guy blew up on me. He said, you've gotten me lost. That's not fair. I wouldn't have gotten lost. I navigate perfectly. And this is totally ridiculous, and I'm not going to do it. And I said, in that case, and by the way, I was circling the airplane by this time. I said, I'm going to circle right here so you can figure out where you are. I'll fly the plane for you while you do some pilotage. And he said, no, this isn't realistic. And I said, oh, but it is. I said, there's going to be a time when you're going to get lost. And he says, no, I'm not. No, that's not going to happen. And I said, in that case, I'll circle till we run out of gas here. But in the meantime, you better get to work. And I was very, firm and assertive, but diplomatic. Mm-hmm. So finally he decided, he grumbled about how it wasn't realistic, but he got to work. And he finally figured out where he was. He plotted a new course back to our original starting point and took over the plane and flew us back and, succeeded in doing what I'd asked him to do. Well, a couple of weeks later, I sent him out on solo cross countries. In other words, where he went cross country on his own. And I worked with him. We worked in the same lab at McDonnell Aircraft together. So he comes in after one of these solo trips to the lab one day and kind of, with his head down, and he comes up and he says, hey, Ray, he said, that exercise you made me do to figure out where I was, and I told you I'd never get lost. Uh-huh. Said, well, guess what? It paid off. Because on one of his solo cross countries, he managed to get himself lost, and he had to use those skills that I had taught him to figure out where he was and get back on course and find his way home. So.
Sometimes it pays off to be firm and diplomatic and say, you need to figure this out.
Right?
Good teaching.
Amongst instructors, we used to laughingly say, this student thinks they have bird blood. In other words, that they're going to instinctively know how to fly without ever having done any of it. Mm-hmm. And they always got a big surprise.
It's harder, and it doesn't quite work the way that my brain wants it to work.
I have never met a student pilot with bird blood yet.
After all these years, really? Not even just one?
Not even one.
Where can people find you, Ray?
By all means, drop me a note at ray@twit.tv. That's ray@twit.tv. I love to get your email. I can't answer every one of them. If you send in your questions or topics you'd like to hear about, I'll try and get to them in the show. We've got lots of topics ahead of us. Next week, we're going to finish up this navigation sequence. And then we've got lots of things. And another show we're going to do is the density of hot air, which is about hot air ballooning. Learning how to fly, some of the stories from that. Remotely piloted vehicles, drones. Flying radio control model aircraft, which is connected with RPVs. Flying light twins, float flying. And I'm trying to get a guest on that's an expert in flying helicopters. So we've got lots of neat stuff ahead of us.
This all sounds wonderful. Wonderful. I'm so excited about it. I am extremely excited about it. And that does it for another episode of Maxwell's House. There's so much more aviation and information and excitement coming in the next few weeks, and I'm going to be here, sucking it all up, sucking the education out of this show as I can. I'm Dr. Kiki, and we'll see you next week. Stay tuned. Keep flying.